We'll clear them up tomorrow. Moving on to 0-6, I was going to highlight some of the other examples that are tricky. I think you know how to do square roots, but I do expect, if it's something you're not sure of, to see a factor tree. So this would be, I don't know, 4 times 12, 2 times 2, 2 times 6, 2 times 3. And then if it's a square root, which we don't really put the little square there, it's kind of implied, but it's looking for pairs of things. I have a pair of 2's and another pair of 2's and a pair of x's. So 2 times 2 times x comes out. In other words, 4x comes out. And I'm left with a square root of 3 because he doesn't have a pair. Here with multiplication, either I can complicate it and multiply it all together, or I can say it's the square root of both of these things, and then I'm just going to do a factor tree, so there's no point multiplying it together when I'm just going to break it apart. 2 times 6. I can see I have a pair of 6's, and I have a pair of x's, so I get a 6x that comes out, and I'm left with a square root of 2 from right there. Same for a division problem. If they are both the same root, meaning both square roots, I can combine them and say it's the square root of 45x cubed over 5x, and I can just reduce. And so that's the square root of 9x squared, and that's a pair of 3's and a pair of x's, so 3x is my answer. We do need to be careful here and remind you that I can't have a negative number inside a square root. That's not a real number. So this x should be positive, and throwing an absolute value sign on there is the easiest way to remember that that x has to be a positive number. Let's try a cube root. A cube root, again, we'll do a factor tree. We know a cube root is, let's see, let's do the 24. That's 2 times 12. And that's 2 times 6, and that's 2 times 3. So for a cube root, I'm looking for 3 of something. So I have 3 2's, and if they were each negative, an odd number of negatives is negative. So I would get a negative 2. And if I have 5 x's, 1, 2, 3, 4, 5, there's 3, so 1 comes out. And I'm left with a 3 and an x inside my root. Make sure that it continues to be a cube root and doesn't magically turn into a square root. That would be one of the classic mistakes. Same thing, fourth root's going to look for what? 4 of something. 2 times 16, and this is 4 times 4, 2, 2, 2, 2. X to the 5th is 5 of these. 2, 3, 4, 5. If I have 4 of something, it comes out. 2x comes out, and I'm left with a 2 and an x inside my fourth root. I'm sorry, I wasn't showing that. Once again, because it is an even root, I have to say that this thing that came out can't be negative. I starred this one because this is for your notes. The number on top is your normal exponent. The number on bottom is what we call the root index. And that's pretty easy to remember because if you think of this as like the ground, the fraction bar is the ground, the roots grow underneath it. The roots grow under the ground. So the root is underneath. That means the square root of 9 to the third. Now, if you really wanted to, you could do 9 cubed first, but I'm going to do the simple way. What's the square root of 9? That's 3. 3 to the third is 27. And that's how you're going to do those problems. One more. We need to add and subtract, but we can only add or subtract like terms. A square root of 5 is not the same as a square root of 20. So the first thing I'd have to do is break that down. This would be 4 times 5, or this would be 3 root 5 plus 2 root 5 minus, this is 9 times 5. Don't forget to multiply your 3 times your 2 to get 6 root 5. So 3 of them plus 2 of them is 5 of them. minus 6 of them is a negative 1 of them. And hopefully that will help you do your homework tonight. Good luck. See you tomorrow.